Hello everyone, welcome back to my YouTube channel. In preparation for building a 2500 West inverter, I would like to share with you a control circuit that utilizes commonly available components while maintaining high efficiency. This circuit operates within a voltage range of 12 volts to 48 volts. Let's take a look at some key functions of the circuit. The first function of the circuit is power on/off control via push buttons. The circuit features two push buttons, each with a distinct function. Additionally, the operating frequency can be easily adjusted to suit different applications and transformer types. The circuit's operating frequency can be adjusted from a few dozen hertz to several hundred kilohertz. For iron core transformers, the operating frequency is typically between 50 Hz and 60 Hz. Meanwhile, for ferrite core transformers, the frequency ranges from 30 kHz to 100 kHz. The second function is soft start and overload protection for the circuit. The control circuit includes a signal pin, which, when activated, will disable all output pulses and protect the circuit. This pin is isolated from the control circuit using a PC817 optocoupler. I will apply a signal to this pin, and you will immediately see the waveform disappear on the oscilloscope. The next function is low voltage protection for the battery. When the battery voltage drops below the preset value, the circuit will immediately disable the output oscillation to protect the battery. The protection voltage can be easily adjusted to suit 12 volts, 24 volts, 36 volts, or 48 volts battery systems. The circuit will not allow a restart until the battery voltage rises above the low voltage protection threshold. The final function of the circuit is output voltage regulation and stabilization. I am currently using the circuit to control a ferrite transformer, stepping up the voltage from 12 volts to 310 volts. As you can see, the output voltage can be easily adjusted. I will provide a detailed guide on how to build and fine-tune a similar circuit after the introduction of my partner, JLCPCB. JLCPCB provides easy, affordable, and reliable PCB and PCBA solutions, empowering electronics engineers to develop projects efficiently. With 19 years of PCB manufacturing expertise since 2006, running 5 cutting-edge, in-house factories and serving over 5.48 million engineers in 180 countries and regions. Order PCBs from JLCPCB effortlessly. Upload your Gerber file to get instant quote and order in minutes. It's as easy as online shopping. PCB customization, component sourcing, stencil manufacturing, and high-precision assembly all in one place. Get 1 to 8 layer PCBs for just $2. Efficient large-scale production reducing costs and bringing you unbeatable prices. Quality and lead time is reliable. All in-house production, ensuring quality stability and strict quality control in every process. Rapid turnaround, lightning-fast PCB production in just 24 hours. Don't miss JLCPCB's 6-layer PCB special. Get $30 off with a coupon and enjoy top-quality 6-layer PCBs for just $5. Plus, to unique finish and no engineering fees for via in-pad. This is the result after 1 week since I uploaded the Gerber file to JLCPCB. I have shared the circuit in the description, so you can download it and upload it to JLCPCB. The circuit is well finished, aesthetically pleasing, and structurally robust. The top side of the PCB has component values printed sharply and clearly, making it easy to assemble the components without any mistakes. This is the circuit schematic. The circuit uses the SG35-5 IC for oscillation generation and the LM358 IC for battery voltage management, temperature monitoring, and cooling fan control. We have two push buttons here, One is used to start the circuit, and the other is used to turn it off. The 12 volts power supply is provided to VR1, which is the TL431 IC. This IC generates a reference voltage of 2.5 volts for the comparator in the LM358. The battery voltage is compared with this reference to regulate the relay operation, thereby supplying power to the SG3525. The 10,000 ohms NTC temperature sensor is connected to the control circuit. Depending on the preset temperature threshold, the LM358 IC will turn the cooling fan on or off to regulate the circuit's temperature. When the SG3525 IC generates oscillations, the output signal is amplified by 4 transistors, enhancing the ability to drive the MOSFET. The output voltage is fed into pin 1, and its value can be easily adjusted using a potentiometer. The circuit's operating frequency can also be easily adjusted using a potentiometer. An optocoupler PC817 is connected to the shutdown pin of the IC. When this optocoupler is activated, the circuit will immediately stop operating. This is the circuit board with 13 input pins. The order and function of each pin are shown as indicated. Now, I will start assembling the components onto the circuit board. This will take some time, but in the end, we will witness an amazing result. Be careful with components like resistors, as they are quite small and can be easily misidentified. Now, I will guide you on how to set the low voltage protection for the battery. First, we need to measure the voltage between pin 2 of the LM358 IC and GND. In my case, the measured value is approximately 2.5 volts. Next, we lower the supply voltage to the level at which the circuit should shut down for protection. Here, I am using a 12 volts battery, so I adjust the supply voltage to 10.5 volts. Next, I will measure the voltage at pin 3 of the LM358 IC relative to GND, then adjust the potentiometer so that the voltage at pin 3 is 2.5 volts, matching the value I previously measured at pin 2. That's it. Now, when the supply voltage drops below 10.5 volts, the circuit will automatically shut down to protect the battery. I will power on the circuit and test the low voltage protection feature. Take a look at the waveform on the oscilloscope and the status indicator LED on the circuit. When the low voltage protection circuit is activated, pressing the button to restart the circuit will not work. The circuit will only operate when the battery voltage is higher than the preset threshold. This is the overload protection function of the circuit that I previously explained. Now, I will apply a signal to this pin, and we will observe the result together. As soon as a signal is applied to this pin, the circuit will immediately shut down. You can use this feature for protection applications, such as overload, overvoltage, overheating, or when the output voltage exceeds or falls below the preset threshold. Everything can be adjusted based on your requirements. I have guided you on how to build a 2.5 kilowatts inverter controller. Wishing you success. In the next video, I will introduce how to integrate this circuit with a 2.5 kilowatts inverter. Thank you for watching my video. See you next time.